So here is another situation for inference of two samples. And that is actually quite different, although it does look the same. So here is an example. We have 20 teachers of French language, and they went in summer to follow a course. And then they had to make a test at the beginning of the course and at the end of the course to see whether the course was actually helpful. And here are the scores: initial test and final test. Okay, so of course, what we want to know is whether the course was effective. And our first intention is to take these two samples. First sample is from initial test and second sample from final test, and run a statistical test for the difference between these two samples. Now, the question is that a good idea? Is that correct? Can we do that? And I'll think a little bit about it. So what were the assumptions of the test for two samples? A very, very important assumption was that two samples are independent. Remember, when we started test for two samples, we had two different laboratories or two different sets of bars that we tasted in two laboratories. Is it the case here? Are these two samples independent, the initial test, the final test? What do you think and why? So the answer to this is these two samples, initial test and final test, of course, are not independent because initial test and final test are both done by the same people. So for example, if you look at teacher number 7, then of course the results of initial test and final test are dependent from each other because these two tests are made by the same person. So these two samples are not independent, and therefore we cannot run this hypothesis testing as we did for two independent samples, because all our tests depend on the assumptions of the model. So then what do we do? How can we do this inference? How can we answer this question? What do you think? So here the approach is actually quite simple. Since our two samples are dependent, these are paired observations, so-called. What we can always do, we can look at the difference between the initial test and final test. And these differences will be independent, or at least can be assumed independent, because the results of different people can be safely assumed to be independent. And what we achieve with this, instead of two samples, we now have only one sample, the sample of differences. And therefore, we can use all the methods that we used for one sample. So again, these two samples are not independent. This is a case of so-called paired observations. It should not be confused with the case of two independent samples, because all the methods will be different. And now we will work with only one sample, which will be final test score minus initial test score. Okay, so how do we do that? That actually, you might actually do it now yourself, because that is exactly the same as we did for one sample. But let's just go through it quickly. So we have a model, and remember that model is for the differences. So this x1 to x20 are independent identically distributed, or you can also write mutually independent if you want. It's the same. They have all normal distribution with unknown parameters mu and sigma squared. Okay, and we have statistical test for the difference. So that means that null hypothesis is that mu is 0, so there is no difference, and alternative is mu is positive, so meaning that there is some positive influence of the scores. So of course it is just t-test as for one sample. So we have this data, sample mean and sample standard deviation. We can compute the t-statistics. It will be equal to 3.99 in this case. We're already very hopeful because it sounds like quite a big value. And indeed, critical value in this case will be 173. So H naught is rejected. And that means, sorry for that, H naught is rejected, and that means in words that we are very happy that the course was actually helpful and the teachers have improved. Okay, so we can also use the methods for one sample for the confidence interval. So, for example, we can say, okay, what is the precision of the estimation of this improvement? So our average improvement is 2.5. What is the precision of this estimator? Okay, so again, it is for one sample, so we use again exactly the same confidence interval as we used for one sample, and when we substitute the numbers, we will get a confidence interval between 119 and 3.81, and this is actually very good because that means that 0 is not included in this interval, so the estimator is positive, but also the margins of estimators of this estimator are also in this positive region. So if probability 95%, the improvement is between these two scores, and in any case, there is some improvement. So what is very important here in this construction is to realize that what is the difference between independent and dependent samples. So in this case, you have to realize that it is a test taken by the same people, so the two samples are not independent, and therefore you can have to consider the differences. It is a very different situation with the one when we have 13 bars with paint and 13 bars without paint. These are 13 different bars. So that would be the situation of two independent samples. And then we have to use the inference for two samples. But here we have dependent values, dependent observations. They are paired observations, and therefore we have to consider the differences. So that is a very important point to realize when you set up your model and when you choose what method to use.